afternoon, everybody, or good morning, wherever you are. Um, I am coming to you to let you know that our class is going to be a little bit different. The reason for this is because um, in past class, many students were not able to hear me or were not able to see what is happening. And so I'm making this tutorial for you so that you can do this basically on your own. And while you're in class, if you have questions for me, I'm able to answer your questions. I'm also able to give you feedback, which I will be doing each and every one of these lessons. So we are going to go right now. So what we're going to be doing is we're going to be going through the lesson, um, and I'm going to walk you through what is the expectation for each one. So that way you'll be able to kind of copy what I do or have an understanding of what it is that you need to do for each one. All right, so for ado now, we're supposed to describe the evolution of relationships between the species represented on the phylogenetic tree. It's not above, it's on here, over here on the left. And so you need to talk about these two species. Let's change up the color a little bit. That one right there. And you need to talk about these two. The reason why these two are the same color is because they're on the same node. This one is on the same node, and this one, these two over here are on the same node. See last class lesson for what is a node. So in your description, you should have something about W and V. Are they closely related or no? You should have something about X. Notice X is all by itself. So there's a special name for that. I'll give it to you here. It's called the out group. And you should have something about Y and Z. Okay. Are they closely related? Are they not closely related? Okay, that kind of thing. And why. You're going to make a nice description. You're not going to put them in points like this. I'm just doing this as a way to show you what is expected. This is not what your answer should be. Your answer should be a whole sentence, actually multiple sentences describing these three relationships. It should be at least 3 sentences. Okay. Now on slide number 3 here, we're going to you go read through your aim and your agenda. And then you're going to go over to slide number 4, building a body of evidence, part 1. And to do this, you're going to zoom in over here on the left. And on the left side of the screen here, there is this diagram. And there's some things I want you to take note of. Just like before, that X was the out group. The lancelet here is the out group. What makes it the out group is, if you look here on this chart over here, you'll notice that the lancelet has 0 similarities with any of the others. Hence, it must be the out group because it has nothing in common with the others. The lamprey has something in common with all the others, and that thing is called a vertebral column, which is the backbone. So the lamprey has one thing in common with everything else. So it's the next closest thing to all the other creatures. The creature that has the most things in common, or the most advanced of the features, is the one that will be all the way down here. The one with the least is the out group. And you can see that being portrayed here. Now, one thing that you haven't seen before are these characteristics here. The vertical column, the hinge joints, the four legs, the amnion, the here, etc. Okay. What I want you to do on this slide is insert what you see and what you think it means. I'm going to edit this so that you have an example of what that will look like. But put in things that you see and give a possible explanation. For example, I see the lancet is an out group. That means it has nothing common with the other species. Right? You make your sentences in accordance with that. Now, for building a body of evidence part 2, what we're going to do is we're going to try to make this phylogenetic tree here by using the information that is above. So the first thing that I would do, I would look for the creature that is the outgroup. And as before, we found out that the Lancet was the outgroup because it had nothing in common with the others. So I'm looking for the one that has nothing in common. The pluses are the things that they have in common. The zeros mean that they have nothing in common. So looking at my lamprey here, all zeros. That means that the lamprey has nothing in common with the others. Okay, so my lamprey would therefore be the outgroup. My outgroup is going to be the one that is all by itself. So here we notice this one is all by itself. It didn't have any nodes, branches attached to it. So that's the outgroup. So on this one, my outgroup would be over here. So I'm going to click my text box and put lamprey over here. Okay. And the second one that I'm going to look for is the one that has the most. So if you look at the leopard over here, leopard has all of these traits. So I'm going to look for the creature over here that has the most. And when I look, I see that the bald eagle here, don't want that, I want this one. The bald eagle here has the most traits. So I'm going to put my bald eagle text box over here. Your job is to figure out the rest. For everybody writes, you're going to use some of your evidence that you found so far from the do now, building a body of evidence part 1 and 2, to describe how evidence can be used to show evolutionary relationships on a phylogenetic tree. You're going to speak about what you just did, how we were able to find the different parts of the tree, how you knew which one was which. Okay, I need to have at least 3 sentences here for everybody writes. Now, deepening the body of evidence, deepening the understanding, sorry. On this slide, what you're going to be doing is you're going to be doing the opposite of what you just did. In you're building a body of evidence part 2, and part 1, you looked at all the things that they had in common, similarities. In this slide, we're going to be looking at the differences. Okay, so let's zoom in on this differences here. Okay, so it's going to be the opposite thinking of what you had before. So species 1 here has 0 differences. What does that mean? Does that mean that it's the outgroup, or does that mean that it's the creature that we're actually looking at to be the one that has the most similarities? A 0 difference equals 100% similarities. Okay, that would mean that species 1 belongs right here. Okay, and if that is true, then the species with the most differences would belong over here. We can see that species 5 is the one that has the most differences. Okay, so on slide 4, the lamprey, the lancelet, had no similarities, which means that it had the most differences. On slide 5, the lamprey had 0 similarities, which means that it had the most differences. Over here, species 1 has the least amount of differences, which is 0. That means that it has the most similarities, therefore it belongs over here, and species 5 belongs over here. I know it's counterintuitive to what you thought, but this is the way that empirical evidence works. So you work forward, and then empirical evidence allows you to work backwards. This is helping you with your empirical thinking. Your job is to figure out the middle pieces. Key points. Today we only have one vocabulary word to be defined. You can use Google or any search engine to put in your definition. You will also need to put your key points in your notebook. Your exit ticket is going to be very similar to slide number 7, sorry. Okay. Your job is to create said phylogenetic tree based upon the differences, not similarities. Okay. And while you work, I'll be giving you feedback so you'll know if you're on the right track. And finally, there's a quote here by Richard Dawkins, a very famous evolutionary biologist, or evolutionary scientist, I should say. I want you to read the quote and tell me if you agree with it or not. And then that will be it for today's lesson. If you have any questions, please reach out to me. You can reach out to me via email, or you can reach out to me in the chat in Google, in the Zoom classroom. Have a good day.